Okay, so same type thing here, guys. This is a discrete relation or function, depending if we decide it's a function or not, but it's discrete in that it's just a bunch of ordered pairs. Okay, so let's look at the domain. And we're looking at the x-coordinates, -2, whatever, -1, whatever, 2, or I'm sorry, 0, whatever, and 3, whatever. So it looks like it's -2, -1, 0, and 3 would be the domain. -2, -1, 0, and 3. Now the range are the y-coordinates. So -2, 0, and 2. -2, 0, and 2. Is it a function? Well, we can tell that if I drop a vertical line, it's only going to hit one point. Also, I see that there's no repeated x value. So yes, it's a function. This next one is continuous, but it is bounded by either side. It's not like it goes on forever. So the smallest x it's going to be is -3, and it's actually not going to equal -3. It'll equal -2.99999, but it's not going to be -3. It can be any x value in between continually until 3. So it's -3 to +3. Notice there's an equal to sign at the +3, but just a greater than sign. -3 is less than x, or x is greater than -3 without the equal to sign because of the open circle. Now, as far as the y-coordinates go, it looks like the smallest y-coordinate is down here at -3, and the biggest y-coordinate is right here at 0. They're both included because I can be, -3 will be a y-coordinate. 0, -3 is on the graph. 0 will be a y-coordinate. 3, 0 is on the graph. And it is a function because I'm not going to be dropping a vertical line that will hit that thing twice. Okay? Discrete, continuous. Okay, here we go with some more of these continuous graphs. They're not asking, well, yeah, I guess they are asking if it's a function or not. Okay, so we have this nice function here, and we're trying to decide what the smallest x value is, which looks like right here at -4 is the smallest x value. And the biggest x value, and it looks like this does go on forever. So it looks like I'm going to go x is greater than -3. And that's all we can say. It goes on and on forever. It can be, I'm sorry, that's not -3, is it, guys? What is this right here? Drop down, -4. X is greater than -4. Okay, I can have a negative, it can't be equal to -4. Okay, it's just greater than -4. So be careful. Don't put the greater than or equal to. It's just greater than -4. Okay. I could be, I can't be -4, but I could be -3.99999. I can be -3. That's -3, 0. I can be -2. I can be -1. I could be 0. I could be 1. I could be 2. It just keeps going up higher and higher. Okay? So the domain is x is greater than -4. The range, let's see, the smallest y value looks like it's at about -1, and then it goes up forever. Okay? So y is greater than or equal to -1. Is it a function? Yes. No vertical line is going to hit this more than once. Okay, these are half bounded. It's bounded here, but it goes on forever up there. Okay. This one is also half bounded. It looks like the domain is, let's see, this is the smallest x, -2, and it goes on and on forever. So x is greater than or equal to -2, because this is a closed circle, unlike this one, which was an open circle. Okay? The range, well, gee, it can go down forever. So, but it looks like the biggest it ever can be is 4. So y is less than or equal to 4. 4 is the biggest y it's going to be. And then it looks like I have y values forever underneath. Okay, so y is less than or equal to 4. Now, is this one a function? Yes. There's no vertical line going to hit it twice. Okay? And then this is the notation we use often for all real numbers. You make like a big R with, instead of just R, you make 2 lines and then R. That means all real numbers, -infinity to infinity. Okay, so the domain here, it looks like x could be, I mean, even if x is -4, you know, since this goes forever down and forever up, the domain is all reals, the range is all reals. I can have any y or any x. It's a continuous. Those arrows on either end just mean, yeah, it's continuous everywhere. And it is a function. This one, still the domain's all reals, the range is all reals. It goes off in either direction, but it's not a function. If I drop a line right here, my goodness, I've hit it 3 times. Vertical line can only hit it once if it's a function. Okay? That's what all real domain and range looks like. Let's try this one. Half bounded here. You know, from this side it's gone forever, but it looks like the biggest x I'll ever have is 2. As far as the y's, it looks like the smallest I ever go is -4, but then it goes up forever. Okay, so x is less than 2. Notice it's just a less than, not less than or equal to. And then it's greater than or equal to -4 for the y's. And yes, it's a function. I'm not hitting it twice. Okay. Same type thing here for the other equation. Oh my, it looks like the domain has just gone off in either direction with x, right? My goodness, I can be anything. All reals for the domain and all reals for the range. Granted, this is going slowly, but it'll eventually hit every single y coordinate. Okay, so they're both all reals. Hopefully you're seeing that it's not a function. My goodness, how many times did I hit it? 1, 2, 3, 4. Okay, that is not a function. All right. So now I'd like you to go to Desmos. The directions are on Schoology, guys, if you want the link. But you go to Desmos calculator, but you sign in as a student. So if you just type in Desmos student, it'll probably come up. But again, you can go to Schoology and I have the directions. Log on as a student and use the class code JYVJNC. It's kind of tough, okay? It's a card sort. Functions, different functions like what you saw. You know, there might be a function like this and it asks you to match its domain and range. It's going to take a little organization, a little doing, okay? But please do it so that you understand for the concept check and some other homework we'll have. Okay? All righty. See you in class.